Welcome to NASA Television. I'm Ellen Stofan. Throughout history, women like computer mathematician Katherine Johnson and astronaut Sally Ride have made unprecedented achievements in space exploration. They have served as role models for young women and men in the United States and around the world. They inspired me to pursue a career in science and eventually led me to where I am today, serving as the chief scientist of NASA. A lot has changed since Katherine Johnson calculated trajectories for some of the Mercury missions, including John Glenn's first U.S. orbital flight, and Sally Ride became the first American woman in space. Recently, European Space Agency astronauts Samantha Cristoforetti and Elena Serova of the Russian Federal Space Agency worked together on the International Space Station, marking only the second time in the history of the ISS that two women have served on the same expedition. My friend Cady is here to introduce us to Samantha and Elena.
Every day, 16 times a day, our space station orbits the Earth, usually with 6 people aboard. Today, we're going to hear from 2 of them. I actually got to spend 6 months aboard the International Space Station, and I really loved every single minute of it. It was amazing doing experiments that I knew were going to be part of the future, paving the way to Mars. Now, all of us that are astronauts, we come from 16 different countries, many different technical fields, but we actually have a few things in common. I think that almost all of us, when we were trying to figure out what career, what field, which fork to choose in a road, all of us chose things that we were passionate about, that we felt really strongly about. And along the way, as we followed those paths, we made sure that we acquired the tools and the knowledge that we needed to be part of those fields and also to be members of teams. Today, we're going to hear from Elena Serova and Samantha Cristoforetti. They are extraordinary women who, when you read these biographies, Samantha Cristoforetti is an Air Force pilot and an engineer. And Elena Serova is an aeronautical engineer of the highest caliber, also a wife and mother. When you read those, realize that they're people just like you. They've chosen paths that they are passionate about. They've done their best. And look where they have ended up. They have chosen to be prepared for the future. They've taken a few minutes out of their day today to share their thoughts on what it's like to live and work up at space. So let's go hear from Elena and Samantha aboard the International Space Station.
I like to say that you come to space with everything that you are, that you have learned in your life, with all the skills that you have practiced, and some of them are like formal skills that you have learned in college or during your professional careers, and some of them are just things that you've learned in your life, just as being a human being. I'm fortunate that I am with a crew where everybody's incredibly warm-hearted, kind, patient, and those are incredible assets when you live up here, 6 people, and you have a lot of important work to do, and you have to function very well as a team. Those are things that you bring with you, and they're incredibly important. And then, of course, there's more formal skills, like your understanding of technical systems helps a lot. So any kind of technical background you have, any kind of scientific background helps a lot, because we do a lot of science and research here on board. Any operational background you have, we're in an operational environment. We're performing a mission. We are working closely with ground controllers all over the world, and we're trying to make this incredible machine, which is the space station, work so that we can support the mission and all the science we do on board.
Thank you so much. It's a great question, and I would like to say that the development of the biological sciences and natural sciences and studying in these areas is one of the most dominant trend here on board this station. It is very important if we are going to explore other planets, go into the deep space. Of course, it is very important in the long perspective, it's very important to understand how biological subjects behave in space. I mean, people, how microgravity and space environment impacts our bodily functions. And also it is imperative for us to understand how plants will develop on board spaceships during the long duration flights. How can we get nourishment and food from what sources? How can we plant colonies on other planets? So I can go on and on. So it's one of the most important trends in our activities here on board the station. Thank you so much. When I was a schoolgirl, I was a little girl, I was inspired by people who were actually fascinated by space. For example, I had a teacher who was fascinated and thrilled by space and was telling us a lot about space exploration, about cosmonauts and astronauts. That's how my small history started. The reason I'm telling you this, of course, now when I'm here on board the station, when I'm a cosmonaut, and even before the flight, I started telling children and kids what is happening in space, in space exploration all over the world, what's happening on board the station. I started to involve children into discussions about astronomy. So I'm doing everything I can in order to make children fall in love with the sky, with space. I know that among those small kids there are future engineers, professors, geniuses, and scientists. So I think we have to tell them about space. It's absolutely imperative that kids should hear this at this stage. They are all talented. I am sure that in the future they will invest a lot of their knowledge into the development of the science.
And I totally and fully agree. Just like Elena, I also, as a school kid, I was already, I had my eyes set onto space. I decided when I was very young that I wanted to go to space. I think it was a combination of things. I had great teachers already in elementary school who taught me about, the sun, the moon, the planets, in a very fascinating way. I read science fiction books, or in general adventure books, Jules Verne, books about exploring and big adventures, and that just captured my fancy as a child. And then as I grew a little bit older, I got more and more interested in science and technology, and then in flying, in aviation. And even in languages, and in living in different countries and cultures, and all of that is part of this incredible journey of being an astronaut, training as an astronaut first, and now being on the space station. It kind of all comes together. All these big passions, all these things that I'm passionate about, kind of come together in this one incredible experience. And all I can do, and I try to do as much as I can, is to convey my enthusiasm about it and talk as much as I can about it. Also with social media, we have this incredible opportunity now of being able to reach out to many people through new communication technologies. And I do hope, of course, that maybe one kid or two will be inspired by it to pursue a similar career.
Wasn't that great? Those are two special women in a very special place. And yet, I think you saw that they're a lot like you and me.
Thanks, Cady. Samantha and Elena are shining examples of the many women around the world making huge contributions in space exploration. The program you're about to see features a group of NASA women who are making a difference right now on Earth and in space. Together, these are the women who will inspire future generations of explorers to pursue their dreams, as I did. I think you'll agree that they already are.
Every day at NASA, we're working harder than ever to send humans farther into the solar system than ever before. And meanwhile, we're making critical observations of our home planet and how it's changing. We're using robotic explorers like the Hubble Space Telescope and the Curiosity rover to help us find answers to our most fundamental questions. How did we get here? Where are we going? And are we alone? All of this work could not be accomplished without bright and enthusiastic people. Scientists, engineers, technologists, mathematicians, businessmen and women, and communicators, and many, many more. These skills are fundamental not only for NASA's missions, but also for the global space exploration that we're doing. Today, I'm joined by 3 women who are leading the way for NASA, and they work on a variety of different projects. Our discussion will focus on how science, technology, engineering, and mathematics, or STEM, education, training, and skills have led them to successful careers at NASA. These 3 women are leading the way as NASA blazes a trail deeper into the solar system with our ultimate goal of sending human explorers to Mars. Mamta Nagaraja works in science communication in NASA's Science Mission Directorate. LaNetra Tate is principal investigator for advanced manufacturing and nanotechnology in NASA's Space Technology Mission Directorate. And Tara Ruttley is associate program scientist for the International Space Station. You each have very different roles here at NASA, and each of you got to where you are through a very different path. So I'm hoping that we could just kind of start our discussion today by hearing a little bit from each of you about how you started at NASA. Because that's a question that people often ask me, at least. How do you start working at NASA? What's the beginning? And so I was hoping that each of you could just tell us a little bit about the beginning of your career, and then later we'll talk more about how your careers have changed over time. So Mamta, let's start with you.
Sure, so the short answer is I started at NASA because of the student programs. And Johnson Space Center has a co-op program, and now it's called the NASA Pathways program. And what that means is you go to school for a semester, and then you go to work for a semester, and you go vice versa until you graduate. So you delay graduation a little bit, but the upside is you get experience at NASA doing actual real work in whatever field you've chosen, whether that's technical or non-technical. But if I can step back a little bit further, I'd say I started at NASA because I had a sister who was interested in science, and she was in awe of the space program back in the early 80s, and that's when Sally Ride had just gone up into space, and she was 7 years old herself, and I think I was 3. And I was inspired by her because she would bring that back to us. And the more I saw her get into science, the more I got into science. And then she kind of grew out of it, and I just delved into it. And it was all I wanted to do. I was interested in the world around me, answering the questions of why. But I must have been so annoying as a little girl because I would just ask, but why is it green? Well, why? Why do leaves change colors? Why do they fall from the tree? And it was just answering the why. So I think that's really what led me to NASA.
Excellent. I like that. LaNetra, how about you?
So I grew up in Florida. So I grew up around the Kennedy Space Center and seeing the space shuttle launch, and an opportunity that I shared with my parents. It was very exciting for me. Then I had the opportunity during my PhD work at University of South Florida to actually work with scientists and engineers at the Ames Research Center. So I had that connection to be able to work with scientists and engineers and gain that inspiration, that motivation, say, wow, what I'm working on is somehow contributing at that point to a NASA mission. And so I was fortunate enough to join Kennedy Space Center when I received my PhD in 2005, and was able to do so many hands-on and activities and projects, as well as actually, now that I've watched the space shuttle launch from afar, now I could see it up close behind the gates of NASA. So that's how I started.
Very cool. And Tara, what about you?
Yeah, so I've always loved science from a young age. I think second grade is when I wanted to come to work for NASA. Okay, I actually loved dinosaurs and space, but who doesn't? So I took the space path, and growing up, people told me, well, if you want to go work for NASA, you need to be an engineer. And you need to do well in school, and you need to study your math and get your engineering stuff done. But when I got into high school, I really fell in love with biology when we dissected a cat. And I love cats, don't get me wrong, right? But that's nature's best design. That's not a feat of mechanical engineering, that's nature. And so I really understood from then on I really wanted to study science, biological sciences, life sciences in the space realm, because I think that gets at the core of trying to solve what we all want to know, right? Who are we? Where are we from? It's philosophical, but it's interesting. Like Mamta said, don't you want to know about the world around you? What is this we're part of? So, so I was able to go to college. I pursued biology. And while I was a student, I participated in all of the NASA student programs that we could ever possibly participate in. I took every opportunity, and I was very fortunate to get hired on at NASA out of my master's degree. Ironically, my master's degree ended up being in engineering, because as I was going through my biology degree, I realized to really get some of the points across that I wanted to get across, I needed to understand some engineering, some hardware, right? So, so I went to work for NASA as an engineer in biomedical engineering, though. So.
Yeah. Wow,
Yeah.
Very interesting. It sounds like you all kind of are very curious people, which is part of the formula, I think, for getting a start at NASA. And so, Mamta, I have to bring this up because this is really cool. You were a semifinalist in the 2013 astronaut selection.
Both Tara and I actually in the same selection.
Excellent.
Yeah.
Very cool. So, I'm curious, what is it that made you want to do that? And then also, what do you think it's going to take? What is the traits and characteristics of what's going to be needed for the first human crewed mission to Mars?
Oh boy, yes. So, what was the first part of the question?
Why did you want to apply for the
Yeah, why did I
program?
want to do it? So for me, I think it's exploring the unknown, not knowing it. It all goes back to that curiosity question, the why. What's out there? And if we can push the boundaries, why don't we push the boundaries? How can we get there? What do we need to get there? So these are the different things that delved me into wanting to apply for the astronaut candidate program. Plus, I think just the little side of me, I think it'd be really fun to see Earth from that vantage point. There are very few people in this world who can say they've seen our home. And I think that for me would be the personal reason why, aside from the technological reasons and the scientific reasons, I would love to see our home from that view. We've only seen it in a picture, like most of us. What would it be like to see with our own eyes?
Yeah.
I think that'd be amazing.
Very cool.
The characteristics I think it'll take for somebody, and Tara, please jump in whenever you think of something that I haven't said or bounce off of each other. I think for one, it's a long trip. So you're going to need somebody who can handle that psychologically. You'll only be around your crew members, and you'll be in something larger than a tin can, because we've gotten better at building these spaceships, but it's still a confined space and you're around the same people. So I think you'll also need somebody who can work on a team. So if you're somebody who can't really be around people, that may not be the job that you'd want to go all the way to Mars. We're talking about no less than 6 months one way, no less than that, depending on how propulsion technology advances from here to when we actually build the ship that'll go. What other things do you think, Tara?
I think you need to be flexible and be ready to accept anything. And you know, obviously NASA does everything as safely as possible, and we try to anticipate every possible scenario. But I think you need to be in touch with who you are and your life and the world around you, philosophically speaking, and also be ready for anything, to be flexible, not just the personalities, but how good at you are, or how confident are you in making decisions that are maybe life or death, or, you know, don't cut the red wire, cut the blue wire, those kind of things, right? So I think just be able to be make good judgment calls, be a good team member. I think those are the things.
Excellent. Thank you. And LaNetra, in your title, we mentioned a big word, nanotechnology. I'm wondering if, for my benefit and others, if you could give us a quick kind of 101 on what is nanotechnology and why should we care about it?
So nanotechnology is essentially the S, T, and E, and of course the M in STEM, the science, technology, and engineering, conducted at the nanoscale. So that's around 1 to 100 nanometers. So if you think about a sheet of paper, it's about 100,000 nanometers thick. Oh, wow. Or your hair is somewhere around 80,000 to 100,000 nanometers in diameter. So we look at this science, this field of science, to help us in areas in lightweighting material, vehicles, potential shielding. If we could get aluminum shielding, enhance that a little bit more. High-speed computing with nanoelectronics. So NASA's delving in many areas in nanotechnology, and we have been for quite a while. But in our everyday life, nano has found its way into sporting equipment. It found its way into corrosion material for corrosion-resistant material. So nano has been around for many, many years, many, many decades, many, many centuries. And it started with Richard Feynman and understanding the power of small. So nanotechnology, much of nanotechnology is core in STEM applications.
Very cool. Thank you. That's a great explanation.
Yes.
I think I get it.
Yes.
Yeah. So Tara, I was wondering if you could tell us a little bit more about the space station. One of the things that I think very few people realize is that we're actually conducting scientific research there all the time. And it's, experiments, plant biology, combustion, all these big, exciting types of experiments. But then there's also this whole category of work being done up there in which the astronauts are the experiment. They're the actual subject. And since you have this background in exercise physiology and neuroscience, I was just wondering if you could tell us a little bit about what we're learning about humans and human health in space.
Oh yeah, I could talk for a whole hour on that. But the space station is the coolest laboratory you'll ever get to participate with or in. I mean, it's all of our labs, right? And so, the human body is the most obvious thing that changes up there, right? We are creatures of the gravity environment. We're developed for Earth. So the second you get off the planet, things start to change. Your body, you'll get motion sick because your inner ear, the fluids in your inner ear kind of get confused. Your eyes get confused because there's no up and down. There's no pressure on the bottom of your feet. So you're floating, and so your body doesn't know which way is up, and it kind of makes you a little ill. And over time, because you're not standing up all the time, you lose bone and muscle if you don't exercise, because again, we're creatures of Earth. Your body's really good at getting rid of whatever it doesn't need to maintain. Your immune system changes. You may get sicker quicker. Let's see, we've got vision issues. Some of the fluids shift to your head, get puffy face, which makes it hard for some of the astronauts to see very clearly. But so there are lots of changes that happen in the human body, and we're the most obvious change. But across the whole scientific spectrum, we have little microorganisms that change, like bacteria. Some become more aggressive, some become more stationary, don't do anything at all. But we've seen some microbes, some bacteria survive the environment of the outside of space station. And so it's really interesting when you talk about the nanotechnology, the particles. She's talking about things that, nanotechnology and materials that you can see and touch based on what we know here about Earth's gravity. But you send those particles up to space by themselves where there's no gravity forcing certain interactions. These little tiny particles will start to behave in ways you would never have predicted. They can assemble themselves, they can disassemble, they can form brand new structures we've never seen before. So using that research laboratory as a way by which, think of any science experiment you've ever done on Earth and take gravity out of that equation. What could you possibly get out of that? Sometimes we don't even know. We just sent up some worms that we cut their body parts off, right? Because we know that worms can regenerate here on Earth. How could they do that in space? So isn't that something we always want to know? What would happen if? What would happen if? So now we have the opportunity to send new and cool and interesting science experiments up to the space station and get some fascinating things out of that.
So Mamta, you said your new job, your title in the introduction is you're working on science communication. That's something that I care a lot about as well. I work in that as well. And I was just kind of curious, how did you get into that? And I mean, it's pretty different than mechanical engineering. I'm just wondering, what type of science communication are you working on, and why are you doing it now?
Yeah, so I would say that actually goes back to probably around freshman year in high school, high school. We had it in our middle school time frame back then. And I had an English teacher who actually is the one who told me to go into engineering. And I grew up in a small town in West Texas, and nobody came to our school to tell us what. I didn't know. I thought engineers drove trains. I mean, that is literally what I thought engineers did. So I didn't know quite what engineering was, but my English teacher had told me about this primarily because I was good in math and science. But the reason she told me that I would be a good engineer is because I was really good in her class, which was English. And it's because I understood how to communicate. I understood the importance of being able to write, which, by the way, if anyone does go into a technical field, somebody who knows how to communicate both verbally and written will excel beyond all of those other people around you. Because most of the people in those fields can't do that. So you having those skills makes you stand out above them. So I think I've always taken towards being able to talk about what I'm doing. And I do enjoy, I have all of my degrees are in technical fields, and I actually enjoy the technical aspect as well. I like getting hands-on and taking something apart and putting it back together. If something's broken, like you're talking about on the space station, or even making a part for something that's broken, going long distance, I enjoy those kinds of things. But I think another part of me enjoys just as much being able to tell people about those things and being able to tell them in a way where maybe they might care about it. So relating, and I think that's what communications is. It's conveying what we do here at NASA in a way that people can relate to it. So why do you care that we're talking about 3D printing? Why does that matter to you, you being the general person in the public? And I think that's really what science communications is.
Excellent. Thanks. It sounds like pretty exciting work.
It is exciting.
I'm excited for you. Very cool. And Tara, speaking of communicating with the public and telling the story of NASA, we've got a pretty big story coming up this year. We've got the first one-year mission on the space station. It's going to be happening in 2015. I'm wondering if you could tell us a little bit more about what to expect during that mission and why it's important.
Yeah, that's right. So we have our first one-year crew going to space station, and they launch on the 27th. So what's that, this week, Friday?
Friday.
Wow. Scott Kelly and Mikhail Koroviyenko. Oh my gosh, I always butcher his last name. I apologize. They're going up. They're going to stay for a year. Most astronauts stay, and cosmonauts will stay for 6 months at a time, but they'll be there for a year, which will give us some critical science data points as to what happens to the human body the longer you stay. There have been a handful of cosmonauts who have stayed in space longer than a year, but this will be the first time actual planned systematic data is going to be collected. So what happens to the immune system, what happens to the bones, what happens to the muscles, what happens to your body as you get past 0.6 months and past a year? Do things stabilize? Do they get worse? Do they get better? We don't know. It'll be interesting psychologically too to see how these crews will interact. Those guys will be up for a year, but in the meantime you'll have different crew members rotating through the station throughout their 1 year span. So I think it'll be interesting scientifically when the results come back. Also, Scott Kelly has a twin brother who used to be an astronaut. He's now going to be looked at the same time on the ground, kind of running parallel studies on the twins, on how the astronaut in space is doing as opposed to the twin on the ground. And the twin, Mark Kelly, has flown before too. So interesting science, fun stuff. I think very new and exciting things that scientists may never have seen yet. That's another really cool thing about getting to work on the space station is we see a lot of new science that nobody's ever seen before. So could you imagine being the first one to see some kind of new data that you get to make sense of? So that'll be really fun. Yeah.
Excellent. Very cool. Now, we talked at the beginning about how each of you started your career at NASA. And now I'd like to kind of shift gears into sort of how your careers have changed. I mean, we've touched on it a little bit, but I think it's, at least for me, it's always really important to kind of reflect on how, even though we might have like one kind of what seems to be a very obvious path when we're young and when we're just getting started in school or choosing a major, choosing a first career, it at the time can feel like that's it for the rest of your life, right? But I think what's so liberating is getting to then change your mind and make a different choice and choose a different career path. I mean, I started out as a scientist and then I became a filmmaker and now I work in science communication. And I know each of you has kind of like a similar, story. And so I'm just wondering if you could tell us a little bit about sort of how your careers have changed and what that's been like for you. Anybody want to start? LaNetra?
I'll start. So in high school, I was part of the International Baccalaureate program. I was one of the first cohorts in our county, Hillsborough County, Florida. And coursework, very challenging, very intense. And by far, chemistry was my most challenging. So I decided to conquer that and majored in chemistry. So I got my undergrad in chemistry as well as my PhD work in chemistry. And so when I started at Kennedy Space Center, I worked in conductive systems and carbon nanotube technology, a lot of chemistry. And throughout the years, I have moved to more engineering type work. And now at headquarters, I'm essentially a champion or advocate for other scientists, other engineers, and their technology. So that really, at times, I step out of my comfort zone of what I was trained to do. And my husband always likes to introduce me as a rocket scientist. And I always tell him, no, I'm really not. I'm just a chemist. But, you know, I have to talk to the propulsion engineer. I have to talk to the metal engineer, the metallurgist engineer. And so I have to step out of my comfort zone so much. And I think that back in high school and undergrad, where I decided to conquer that challenge of chemistry, makes me so much more comfortable stepping out. And it goes back to that communication, being able to communicate and understand different areas, to talk across several different technology areas. I'm still in technology, but I'm not necessarily mixing chemicals in the lab. I'm actually talking across a broader community.
So for me, I think the answer comes in what I was told in high school. I grew up in Louisiana. We made a field trip to the Johnson Space Center, and we got to meet an astronaut. And I said, so what does it take to be an astronaut? And he said, well, just enjoy what you're doing, because whatever it is, you do what you love, right? Because if you do what you love, you'll be successful at it. And so I took that, and I constantly kept that in the back of my mind. And as it turns out, he was right. So everything that I've done up to this day is because I've enjoyed it. And as that enjoyment comes success, and then more success brings more opportunities, and more opportunities brings more fun. And so all of us are up here because we love what we do. When I came to work at NASA as an engineer, it wasn't what I had planned, but it was the perfect fit. Someone else saw that in me that I didn't see. And that's another thing. I've been able to trust my mentors, or trust those who see things in me that I wouldn't have otherwise seen. And then once I got here, I was able to, got to NASA, I was able to pursue my PhD in neuroscience at the same time, working and going to school. So once I completed that PhD, I'd been in engineering for about 8 years, and I thought, you know, it's time for a change. I'd like to do something in science, and that's what I'm interested in. That's my passion, and I was fortunate enough to apply to this position that I'm in now as Associate Program Scientist for Space Station. So I don't wear a laboratory coat, and I don't work in the labs anymore, but I get to manage all the research that happens on station. You get to meet the scientists, you get to touch the stuff, you get to help train the astronauts on the science that they're going to be doing, you get to see some of the first results, and then go out and communicate those results. And Mamta was right. If you can be a good communicator, it's fundamentally what we do as human beings. We have to communicate to each other. Sometimes we get it right, sometimes we get it wrong. Mm-hmm. And it's a challenge to get it right. But if you don't get it right, you can see a lot of consequences that happen. So if you're good in English, definitely take that and apply it if you also have a love for science. If you're interested in mixed arts, physical, musical arts, visual arts, and you have a love for science, there's ways that you can marry both of them and be contributors to society while you're also self-fulfilled. So I live that every day. How can I be self-fulfilled, but also how can I contribute to America, the world, and you just, I think all of us up here are just conscious of those things. And again, if you just keep doing what you love, you can change paths, and you just keep following where you're meant to go.
Yeah. If I could add, doing what you love it reminds me of Katherine Johnson, who's joined NACA when NASA was NACA back in the 1950s, and she was a mathematician. She helped with some of the trajectories of Project Mercury and Apollo 11. And she started out as a teacher, I think, right? And then she loved mathematics so much that she came into since this is women in STEM, a very male-dominated environment, but she loved mathematics so much, and she loved what she was doing, that, you know, I think NASA has always been an environment that really cultivates, and you really love what you're doing. I think since I started day one, I've actually enjoyed every job, every task, everything I've actually done. And so you just think about Katherine Johnson and all the other women that came before us in STEM fields, that they actually loved what they did to contribute to NASA's larger role.
I'm glad you brought up Katherine Johnson, because that's one of the things in science communication we talk a lot about, increasing diversity and just sort of the face of science, and I would expand that to technology and engineering
Yes.
as well. And you know, there have been many studies showing that, you know, when kids are asked to draw a picture of a scientist, they often come up with a singular look, sort of an Albert Einstein,
Right.
older white man in a lab
Right.
coat, crazy hair,
Right.
you know. And obviously that's not a complete picture of what science looks like, 'cause
Right.
here are the four of us. And I'm just kind of curious, maybe Mamta, if you could just chime in a little bit about how you think the face of STEM has changed over the years, and what we can do to really portray a more complete picture.
And I think it parallels how our nation has changed and largely how the world has changed as well. I think that picture used to be accurate. I don't think any of us could argue that at one time it did not represent your average scientist, but I think we have changed as a population, both in this country and internationally. And I think we represent how that change has happened. I mean, just visually look at us. This is science today. The pictures that these students are drawing it's maybe because they haven't been exposed to or haven't seen what current day science is like. But when I mean, in each of the different times that I've done hands-on technical work, if I walk into the lab, those labs look like us. I mean, I throw in some men, obviously, as well, because obviously both men and women work in those labs, and you should. I think teams of the combined group is actually the strongest group when you have diverse minds and people who come from different backgrounds, not just gender and not just race, but actually their different backgrounds, how you grew up. You approach problems very differently. And I think I hope that someday as students realize that science has changed and they come to these types of events and they say, oh, that's really not what science looks like. Now engineering looks like this. Then that picture will also change and evolve the way that life has evolved, the way that our profession has evolved, our country has evolved.
Absolutely, and I think it's also just super important to have, you know, those role models and those mentors. Like you said, if you don't see other people who look like you in a job that you might want to pursue, then you might be discouraged from pursuing it. I'm wondering if any of you have specific mentors or role models that have been really important to you in your careers. Tara, do you want to start?
Yeah, you know, it's interesting. I didn't actively know I had any I never actually thought I had a role model, and I didn't realize this until maybe a few years ago. I can now look back at who has influenced my life, you know, and mostly spaceflight in general influenced my life growing up. But when I got to NASA, it was my very first manager, who was a math major, African American female, and she managed a whole group of us where there were only two of us who were women in the engineering group. And that I didn't think about that at the time. Wasn't a big deal to me. But then I moved on to the next position and realized, whoa, she shaped my life. She influenced me. She influenced others. That was a major impact. She encouraged me to get my PhD, supported that, and now I'm in a field where my next major mentor in my career is the chief scientist for Space Station, Julie Robinson. She's a woman, and a strong woman in science, a great communicator. I had some great mentorship through college that I didn't know. So I wasn't actively seeking things out. So for me, mentorship was more passive. And I can look back now and probably handpick a few. You know, and with regard to the scientist look, the stereotypical scientist look, I think another thing that females might think about young girls is that scientists are just born naturally smart and naturally able to just do it, right? Dig in and love math and love numbers and love data and get the graphs, get all that, get the charts. It's not always true. Like, I wasn't born naturally smart. I didn't always get the data and the graphs right away, but I was curious enough to dig in and learn how to do it, learn how to read it. And I'm not always the brightest and still not always the smartest in the room, but if you just keep asking the questions, there's no stupid questions, just keep asking and digging. I think that's another thing that will create some of the better scientists in our world.
Yeah. Thanks. Yeah. Any other mentors or role models you guys want to name?
Yeah, and I won't throw out names because I'm afraid I'd forget somebody, to be honest. But I will say, and it's kind of similar to what Tara said, looking back, I realized where the mentors were. And at the time, I don't know, some of the mentors weren't my formally assigned mentors. They were people in the office who just really cared about me. And I just, looking back, I think, wow, he really cared about me, my career, where I was headed, pulled me aside at times and said, you know, I really think you should pursue this opportunity. I think it's made for somebody like you. And I would have never found that opportunity had it not been for this particular mentor. And, you know, in my head right now while I'm talking to you, I can see the faces of these people. But I also, I mean, the one thing that strikes me the most is that none of them had to do it. None of them had to come up to me and say, apply for this scholarship because I think you could get it and end up with a full scholarship to college. I mean, you know, that person did not have to do that for me. So for me, I always say mentoring is, at least when I approach it, when I mentor people, I think it's about wanting them to do better than you did yourself. And that's how I approach mentoring.
Great. I think I have had extremely positive experiences with mentors, starting with my mom and my dad. You know, the ultimate mentors are your parents, because I know with my parents, it's, you know, you can do anything you set your mind to. And I think, you know, there's always that middle school, that high school mentor, and for college, I went to a HBCU, a historically black college or university. And so being a minority in several senses, I had a university campus full of mentors. I remember I was in the chemistry department, and the chair of the department would make a point that all of his chemistry majors he would call doctors. Dr. Clayton. So you'd walk down and that was my maiden name. You'd walk down the campus and he'd call you that. So that was the first inspiration of, oh, I can actually move forward. And as I joined NASA, I've had, like you said, people who really care about you, both in the lab and external at other centers, and both men and women. I've had some really great women mentors, and I've had some really great men mentors. So it's really about those individuals that really care about you and say, you know, did you think about this? And maybe you should think about this. And you really, really have these skills, and these are your strengths, and these are also your weaknesses. And here's how you could help, you know, improve those weaknesses. So I've had really great experiences with mentors.
That's great. Thank you all so much for just sharing your story and your experiences about your careers, but also just kind of how you live your lives. I think it's really inspiring to hear, you know, from such different perspectives and about different jobs at NASA, obviously. It's just a very exciting time to be here at NASA. It's a great place to work, obviously, as we've been hearing from our panelists. It's been recently named the best place to work in the federal government for the third year in a row now, which we're all very proud of. And I think a lot of that comes from the fact that we're all very passionate about what we do. And, you know, for people who are out there who are interested in learning about other careers at NASA, we do have a lot of information about jobs and internships and fellowships on our website, and education opportunities as well at nasa.gov/education. And I also want to just mention, we've been talking a lot about the International Space Station today, and there's a lot of really good information on nasa.gov/station about what's happening in space right now and what we're learning from the science experiments that we're doing there. If you want to follow NASA on social media and enter a dialogue with some of our scientists and engineers and technologists, you can visit nasa.gov/connect. And then lastly, if you want to actually see the space station in the sky, you can check out Spot the Station, which is a really good resource for finding out when the space station is going to be passing over your local area, and you can actually see it in the sky at night, which is really fun. So next, I'm going to invite any members of our studio audience here to join us and have your questions answered by our panelists. Whether it's a question about careers or education or just anything that you might be curious about NASA. And we have a microphone over here. If anybody wants to ask a question, you can take your time.
For the upcoming mission in Mars, what kind of changes and improvements to the space shuttle do you have to make?
That's a great question.
That's a great question, yeah. Who wants to take it? I'll start, but I assume that we'll add to it because I certainly don't know everything that has to change. But the first thing to note is the space shuttle that we remember, the space shuttle from the 1980s and 90s, the one that you're probably picturing, could never leave what we call low Earth orbit. So it could only go and orbit the Earth up to so many miles in what we call in the field low Earth orbit. So the first change that would have to happen is to go back to the early rocket days, like the Apollo rocket, if you remember the one that went to the moon. It would have to, it doesn't have to necessarily look more like that, but the new one does look a little bit more like that. And the main thing it has to be able to do is leave Earth's orbit, and that's called the escape velocity. So it has to be able to go fast enough that it can actually leave the gravitational pull of Earth, which is how anything stays in orbit, is the gravity keeps them there. So that's the first major change that I can think of.
That's a good answer.
And propulsion, right?
Absolutely, yeah.
So we are looking at different types of propulsion to help our vehicles get farther and deeper into space. So propulsion's another component of that.
And it'll help us get there faster.
And help us get there faster.
Yes, and protecting the humans.
And protecting
So the further out we go, we're not protected from the radiation that's felt in the environment. So we have to design the vehicle to protect the humans against the radiation. We have to have a way to get our own food, grow our own food, or somehow make our own food, replenish our water supply systems, and make sure, again, if you're going out there for 6 to 9 months, you're unloaded, your body is floating on the way to Mars for that long. So how will the body react once it lands again on a terrestrial environment that has some kind of gravity vector? So how do we keep the body healthy? Do we keep the exercise going? Those are things we're working on space station right now to try to understand. So from the mechanical to the life, it's a full range of work that needs to be done on that vehicle.
And we're already starting, what you're thinking of, the space shuttle that we're used to, that's in our generation, was the shuttle transportation system. And we've retired those vehicles. They are either, Kennedy has Atlantis, the museum here has Discovery. So they're in various museums. The new launch vehicle, SLS, or the Space Launch System, is we're currently working on the next generation vehicle that will help us get beyond the moon and further into space and Mars. So we're actually, our engineers, our propulsion engineers, our rocket scientists, they're actually working today and tomorrow and the next several years to actually build that SLS rocket and the crew capsule, which is known as Orion.
Yeah.
Thank you.
That's a great question.
Do you think the classes that you took in middle and high school affected your position today?
Absolutely. It's very, very important to, I think that as a middle school student and a high school student, that you should embrace all your classes, English, humanities, math, science, so that you can become a well-rounded scientist, engineer, mathematician. You don't just want to limit your coursework to a math path or a science path. You want to take all of your liberal arts and STEM type courses so that you can become very well-rounded and you can become more informed as you move into your higher grades and into college. So I like the fact that I've enjoyed Machiavelli just as much as I enjoy my chemistry textbooks. So it's important to embrace all of those courses and literature and English and even, we talked earlier about, home economics or family consumer science and shop classes. So embrace all of the coursework and do well. So study hard, read a lot, but enjoy what you're doing as well.
Yeah. And I'll tell you what, so in school, I think what I use the most, and I will be very honest, I don't mix chemicals. I don't do what chemistry has taught me every single day.
Right.
And I certainly don't pull out a formula from math every single day. I don't do algebra. I don't look for X. But what all of that taught me, and I only know it now, I didn't know it at your age, any of your ages, but I do know it now, it taught me to think. It taught me how to analyze a problem. How do I take the given information and come up with an answer from it?
Yep.
So that thought process to go from given to answer was what I learned in school. And that is probably the most important thing I got from school that I use every single day.
So true. And I didn't know it till I got to a philosophy class at the university. And the philosophy teacher said, do you know what university means? Universe, the one truth. You're here to learn the one truth, but to get to that one truth, you have to learn every other part of the world around you. So even if you're not really interested in physics, guess what? You're part of physics every day.
Right, yeah.
And like Mamta said, it's a matter of what you're learning that makes you a whole. All these little pieces make you a whole. And they're all representative of the real world that we live in and that you're interactive in every day. So right now, physics may not be so fun, but you might get to your next level of physics and think it's amazing. It also depends on the type of teacher you have too. So.
Definitely. Do we have any other questions from our studio audience? We've got time for one or two more.
Moms can definitely
Yes.
ask questions.
I heard you all say that you're mothers, and I'm so proud that I'm so proud of that, because I think one of the main issues is a lot of women who are asking themselves in their mind, can I have a family and be a scientist or in STEM? So what advice would you give to a woman facing that question right now?
Work-life balance. You have to really understand work-life balance. Come to work, do a great job, understand when you go home, you have responsibilities at home, but also take care of yourself. I mean, go get the massage, go to yoga class, do what you need to do for yourself, because we're all intrinsically motivated to do a great job in everything we do, not just at work, but at home. And so I know I have to be cognizant of my work-life balance. I don't always do a good job, but I try. It's a living thing. It's a daily checks and balances. But I think that, and also a support system. I not only, my husband is a great support, but I also have community support and my neighbors that are also very supportive. And you have to not be afraid to reach out for that support. And NASA is a great place for women with families, men with families, families with families. It's a really great place to, it's very family friendly in my experiences here at NASA.
Yeah, so it's everything she just said, and it brings to mind one particular point in my career, another one of these defining moments where I was working at NASA for about 8 years before I had my daughter, and I went on maternity leave and came back, and a lot had changed, and things were slower for me. And beforehand, I was like full bore into it. I was there, all day, every day. That was my life. That was my life. I came back, and it was kind of like everything had changed. Now what? And I remember one of my male coworkers came and stopped by my office. He's like, "How's it going?" And I'm like, "I don't know, man. It's just a little boring, and it's just not as challenging to me." And he goes, "You know what? You're a new mom. Why don't you just take that time take this time to enjoy your daughter, enjoy life with her. Work will pick up. You'll get back into your career." And any other woman could have taken that. If you're really sensitive, you could take that as offensive. Like, what do you mean telling me I should focus on my daughter and not come back to work and so hard? But if you're introspective and you really consider what people tell you, you think about it. So I thought about it and I weighed on it, and he was right. I followed that advice. I just threw myself into the motherhood, and the career just picked right back up. Things fall back in line because why? You're happy with what you're doing. You go with the flow, go with what you're happy with doing. And I was really enjoying my daughter. I'm still enjoying her 8 years later. And being in the STEM workforce now, I get to take her along on a lot of the things that I get to do. She gets to tour the labs. She gets to meet other researchers. These are all things I didn't have when I was growing up, none of this access. So being a mom to an 8-year-old in this world is amazing. And I know Mamta's got a 1.5.
Yeah, he's 15 months. He's brand new. At least I feel like he's brand new. I like to keep him brand new as long as
I have
possible.
a 4-year-old.
Oh,
so.
gosh.
So exciting.
A 4.
We're right in the,
Four-year-old.
yeah,
Yes.
1.5.
When did mine get so old?
The one piece of advice I would give to a mom is don't be afraid to ask. And we are fortunate that we have a wonderful place here at NASA that is family friendly, but not all women are, and not all men are either. And we know that the jobs vary greatly in the US, from companies that don't give any type of flexibility to parents, both moms and dads, to places like the government where you have this liberty to have a work-life balance. So what I would say, if at all possible, ask. Don't be afraid to ask, because even in this wonderful life of work-life balance, I still become afraid to ask if I can take time off and make up the hours later to go do this with my son. I still am afraid, and I shouldn't be, because every time I have asked, Sure, absolutely. And if you need, just work from home and then come back, and why don't we do this event here and we'll move this meeting. Every time I've asked, somebody has helped me figure out a way to achieve my goals, exceed my expectations, and spend time with my son. How awesome is that? So if anyone who's watching this is out in the private world, I would say don't be afraid to ask. And if it's at all possible, keep asking until you find the right supervisor and the right mentor who will afford you these liberties if it's at all possible. Because honestly, I had a really hard time, and I still have a really hard time coming to work and leaving him. And even just this morning, he's waving to me, and and he's excited, and I'm the one inside who's just, I can't believe I'm having to leave him. But then I come to work, and I have these wonderful people around me, and I have this awesome supervisor who, on my very first day of work, I thought for sure she was going to lay out expectations that I wasn't going to be able to meet, and that was my greatest fear. And she goes, okay, so what hours are you going to work? And I immediately felt this pressure to say, I'm going to get in at 6 and I'll stay until 4, and I felt this pressure. And so that's what I said. She looked at me, she goes, why don't you just test out the commute and see what it's like for the next couple of weeks? Come back to me and let me know what hours you're going to work, and we'll just go from there. I came back and I told her my hours, and I said, how my plan, the plan that I thought would work for my family. And she said, go home and talk to your husband and just, why don't you just talk about this and think about it? Came back with my hours. She said, okay, that works.
That's awesome.
You're doing great. Yeah. So find that support system if you can find it. And if you can't find it where you're at, and if it's at all possible, try finding it elsewhere.
That's true. And to add to that, basically, guys, this is one thing you should remember too. Never be afraid to ask. If you have a plan, even if it's outside of the normal routine, that's how I got here a lot of. Just ask, create something yourself, put it out there and ask. The worst they can say is no, right? Sometimes you don't start new programs or new pathways for anybody else if you aren't the first one to ask. So what if they say no? You just ask again later.
Ask again, right?
Or bring
Timing
them
is
a new
everything,
plan.
right?
Timing is
everything. I've never applied for a detail assignment. I've always created a detail assignment. Right. Yep. But being a mom should never be a limiting factor. It shouldn't be.
Thank you for your answer, and thank you for being such great role models.
Thank you.
Oh, thank
Thanks
you.
for your question. Do we have one final question in the audience?
In your NASA or STEM career, have you ever actually needed to use algebra?
I use algebra to balance my checkbook. I'm not even kidding. Like if I spent this much and needed that much, then X is this much, Y is that much. That's about it.
Yeah, well, no, I think I have used it, not in like, so in algebra, there's two different kinds of things. There's the word problems. Are you in algebra right now? No, okay. So when you get to algebra, there'll be two different sections, right? There's the word problems. Those, yes, absolutely. I'd say we've all used those.
Yeah.
You get this given information, you got that's what I talked about earlier. You got to find the answer.
The X,
Absolutely use those. When you're talking about your typical like x plus 3x plus 4y equals something, and you have to solve for x and y, you do in the technical world. You do when you are designing a mission, like you asked earlier about how to make changes to a vehicle that will actually go beyond low Earth orbit and further into space. You do actually have to use algebra in those types of things. And a lot of it's also formulas that you have to use.
Yeah, to create chemical compounds and things like
Use it
that
a lot
in the
in
labs.
chemistry.
Yeah.
Right?
But the word problems are algebraic as part of your everyday life too. I
Everyday
mean, you're
life.
always doing algebra, you just don't know
You
it.
just don't know
Yeah.
it, yeah.
Yeah.
And always
it's hard-
solving a problem.
Yeah.
Always.
Always.
And I'd say I figured all of this out when I turned about 30 years old.
I
So
know, it's
if
such
you
a
don't-
shame. It's such a shame. We can sit up here and tell you all day long what you're gonna know, but
Someday you'll know.
yeah.
Thank you.
You're
Thanks
welcome.
for your question. All right, everyone. Well, thank you very much for your questions and for this excellent, rich discussion about careers at NASA for women and for everyone. I encourage you all to stay with us, follow what we're up to, and get involved. We have lots of opportunities for citizen scientists and people who are interested in technology challenges to get involved with NASA and be a part of space exploration with us. So thank you very much for tuning in, and we'll see you next time.